Right, we need to do a little bit of work on 3D vectors. It really is just extending what you did last year for 2D vectors into 3 dimensions. So not that much, to be honest. Just if we talk about 3D coordinates first. So the way these work is your Z axis goes vertically upwards. Your Y axis goes over to the right. And then obviously I can't draw this, but the X axis would be coming out of the board in this direction. If you think about, I don't know if I can do this on the camera, but if you think about looking into the corner of a room, then if the corner's sort of to your left, then the Z is going up towards the ceiling, the Y coordinate is going to the right, and then the X coordinate is the wall coming out this way towards you. That makes sense. I don't know if it does. But anyway, 3 perpendicular axes, X, Y, Z. I could use the board being upright, really. So I normally put the X like that, but it's actually coming out like that. You don't really need to be able to visualise things in 3D, so you can just think about how would it work in 2D and then just apply that into 3 dimensions. So don't worry about being able to visualise these. And then we can talk about a point P as having coordinates X, Y, Z. So a couple of straightforward examples. So first of all, we can find the distance from the origin. I'm just keeping my teaching to match the exercises in your book, actually. So we can find the distance from the origin to the point P. Minus 214. So minus 214. So we've gone 2 back along the x-axis, across 1, up 4, but you can't really draw that nicely in 2 dimensions, so you don't really need to worry too much about kind of where that is, so to speak. Origin we tend to denote with capital O, and so we want the distance from the origin to P, so OP. And Pythagoras extends into 3 dimensions. So it's just the square root of minus 2 squared plus 1 squared plus 4 squared, which gives you square root of 21. So it's just extending Pythagoras into 3D. If you want to find the distance between 2 points, so again, you can just think, what would I do in 2D and extend it into 3? So if we want to find the distance between A, 1, 3, 4 and B, 6, minus 2, 3. If you remember in 2D, to find the distance AB, you do the square root of the difference in x squared plus difference in y squared. So this is going right back to the stuff we did at the beginning of last year. And so we just do that, but in 3 dimensions. So AB is equal to the square root of 6 minus 1 squared plus minus 2 minus 3 squared plus 3 minus 4 squared. And that's equal to the square root of 25 plus 25 plus 1, which is root 51. So this just extends to 3D. We just need to add in difference, I don't know if you can still see that, hopefully, in z squared at the end. So that should be really straightforward. I've just set you a few questions on that, and then we'll just move that into thinking about vectors instead of coordinates.